Welcome to another Unnecessary Computer Things. Today we're going to try to recreate the 10-print maze in Jupyter Ace 4th. First, we set up a pseudo random number generator. These first few words / functions are from the Jupyter Ace manual itself, pages 80 through 84. This first method, seed_on, gets the next random number seed. Seed is a 16-bit integer that jumps around enough from our calculations to look random. The @ symbol retrieves the seed variable, then we manipulate it to get a new value. And then finally, we duplicate it, and then the exclamation point stores the value back out to the variable. Now that we have a seed value on the top of the stack, we can use that in our R&D word. We call the seed_on word to get a new value and then multiply that value by a number n that we placed on the stack to get a random number from 0 to n-1. I'm also going to include this rand word that uses a slightly more random value on a real Jupyter Ace than the fixed seed we start with. The location 15,403 is the number of frames displayed since powered on, and we're going to initialize with that value if 0 is on the stack before this rand call. So there's the dupe 0 equals to test that. This next word, gr, is on page 71 of the manual, and it allows you to define an 8x8 character graphic with 8-bit values on the stack and the character code to assign the mapping to. Locations 11,263 through 12,287 store the patterns for characters 0 through 127, and that's 8 bytes per character and 1,024 bytes total. Then we're going to use a C exclamation point or C store to store a single byte in an address. We're actually starting at the end of the memory slot for the character because we're going to be putting the values on the stack in order for the function, so we have to back them off in reverse. We're using I for the offset that we're tracking in a do loop, and then we're doing a -1 at the end of the loop iteration. We end with a plus loop, which is similar to a branch if not equal instruction in assembly that really just checks if the loop variable is greater than 0. Next, we define two characters using base 2 binary. First, a \like graphics character. The text slashes in Jupyter Ace don't use all 8 lines, but only 4, so our maze wouldn't have the closed-in walls if we used those. And you can see that we're just defining 1 bit on each line, and it's going from left to right. Finally, we switch back to decimal and call our gr word with 1 as a character code to assign this backslash to 1. Next, we're reversing the order of the pixels, and we're going to assign that to the character 2. And you can see here, we're just going through, and it's a little easier to line these up this way because you can just line up the columns as they're shifted over. It still took me a while to think if I was actually marking the right column, so that's why it's a little tedious to watch. And then once we're done defining these lines, we type 2GR at the end of this, or after the decimal conversion, or converting back to decimal, 2GR to say, hey, assign this to character code 2. Lastly, we're going to write the maze word. First, we clear the screen. Then we're going to loop 24 times, or 32 times 24 times, and initialize the loop counter to 0, so they were counting up. And in the loop, we're going to emit a random number and add 1. And then emit just prints that character out. So we should be able to run it now. Okay, so error 2 is a buffer underflow. What broke? So let's try editing the maze word. And if you notice, rand doesn't have an argument passed to it. So we need to put 2 on the stack so it knows to generate a number from 0 to 1. And there we go. Let's make that run a little longer. First, you don't put a colon if you're doing edit. We can make this run a little longer by changing that second number of lines to 38. So it's 32 columns by 48 rows. And so that should fill basically 2 screens. Now, this is definitely not the one-liner maze that like you would see in Commodore, but a nice trade-off with this is that it runs a lot closer to machine code because the words are compiled each time. Also, a lot of the memory access is stacked based because it's fourth. Who can type while being watched? Even if you're pre-recording the watching. Anyway, thanks for watching. Like, comment, subscribe. Let me know what other things you want to see. Thanks.